Okay,
Yes.
so hello everyone. Thank you so much for joining us today. My name is Sinara and I'm going to be your host for the day. It is a bright and sunny afternoon here in Gurgaon, and I hope all of you are enjoying great weather too. The onset of winters here in India poses a challenge for the more high altitude terrains in the country, with heavy snowfall and avalanches pausing operations and leading to a loss of life, livelihood, and livestock. The companies and industries that are working towards aiding in smoother operations despite these obstacles often do not get to tell their story. We at GeoXchange are committed towards driving compelling conversations with the industry's most impactful thought leaders. Today, we have gathered here to talk about avalanche protection, which is truly the need of the hour. Without any further ado, I would like to take this opportunity to introduce you all to our moderator for the day, Dr. T.N Singh. He is the Vice-chancellor at Mahatma Gandhi Kashi Vidyapith. Over the course of his enterprising career, Dr. Singh has been awarded various accolades such as Excellence of Teaching at IIT Bombay, Lifetime Achievement Award by the Neem International Foundation, and many more. In his previous capacity, he worked as the Dean of the Department of Earth Sciences and Rock Mechanics at IIT Mumbai. Thank you so much for joining us today, Dr. Singh. It is over to you now.
Yeah, thank you. Thank you very much for giving my introduction. Uh, First of all, I must thank the organizers who has given me this opportunity to work as a moderator in this international webinar where we are expecting that many more peoples, more than 100 peoples have joined from the different organization. Those who are heading the organization, there is the R&D heads of the different organizations, and moreover, the thanks to the GeoXchange who has done a wonderful work, which is more than this requirement, because this avalanche is a very serious and repetitive and rigorous phenomena across the world. This webinar is sponsored by the Geobrugg India Private Limited. The world leader is providing the solution related to these natural hazards like slope instability, rockfall, debris flow, avalanches, flow landslides, and many more. I would like to thanks our platform partner, AirMeet, and all in the virtual event platforms and communicator partner Scroll Mantra, one of the India fastest growing PR agency. I would like to introduce you to our speaker. Please welcome Dr. Amod Kumar. Kindly raise your hand, sir, so that people can recognize.
Yes, sir. Thank
Thank
you.
you. Thank you. He is Associate Director, Defense Geoinformatics Research Establishment. He play an instrumental role in developing various indigenous avalanche dynamic model as well as different type of this avalanche control structure. Our next speaker is Madam Nadine Feiger, R&D specialist, Hydro and Slow Geobrugg International Private Limited. She is responsible for the project management of avalanches and hydrometer in the technical departments of the Geobrugg. Hopefully, she is in Switzerland. I would like to introduce you, Dr. Rudra, and he is the technical head of this Maccaferri India Limited, and he is associated with this company in the last more than a decade, and he has worked in the several landmark projects of Maccaferri in India as well abroad. So, with this short introduction, I would like to pose my first question to our associate director to start with this webinar, and then we can ask Tara to go ahead with this. So, Dr. Kumar, are
Sir.
there any guidelines available for the management of avalanches in India? Or do we have a regulation for construction of infrastructure in avalanche prone area? And adding more on this, what are the different models of avalanche forecasting at your institution where you are using for the protection and prevention of this avalanches of various kinds?
Sir, our establishment is working in this field from last 5 decades, sir, and we are working for three major parts, sir. One is the avalanche forecasting, other is the avalanche dynamics part, where we understand after the formation of avalanche what will be velocity, flow depth, and runout distance for various conditions. Means the various snowpack condition, means for inputs, fracture depths, and we study this avalanche dynamics in two ways, sir. One is the extremities, means what are the extreme condition, means on the basis of precipitation pattern in various Himalayan regions. We use the similar to the Swiss Institute that 3 to 5 days maximum precipitation and accumulation of the snow is linked with the assumption that what will be the extreme event in which what are the probable fracture mass which can release, and we have various models. So we use here, sir, depth average integration model. So worldwide, for the flow simulation, you have only two options. One, you use Navier-Stokes equation, and in which you use direct viscosity parameter, and you define the resistance to the flow and drag on the avalanches. And second concept, which is used in the hydraulics in water flow situations, we call it depth average integration model, which has many assumptions, but it is very difficult to model the avalanche in real scientific way using the Navier-Stokes equation due to uncertainty in the terrain is very large scale. We are using the depth average integration model, sir. And fundamental equation of the depth average integration model is similar to the hydraulics model. It is we call Cheji or mining equations in the root, but we use here slightly different friction model. We call it volume fluid, where we use the water property or viscosity property. Means you can understand that the velocity depend resistance to the flow is the function of the velocity, but it is also function of the Coulomb frictions. Means we use two type of property here. One is rheological property, other is granular property. Means it's the mixture of two things. We capture the granular part in term of the Coulomb frictions, and we take the rheological property of the snow by taking its as a resistance to the flow is directly proportional to velocity square functions. So on the basis of this, we simulate the flow, and we find out we have our own model through which we define the fracture depth on the basis fracture depth and fracture area on the basis of terrain, its slope characteristics, its curvatures, and other parameters. Once you understand in a particular formation zone how much area can trigger and how much depth can trigger, then after that we have a friction model. We adjust the friction parameter, which is the granular part, and we take the velocity dependent part and we simulate the flow. So we have opportunity to work also with the SLF, sir. We have worked 6 months with Perry water there, and we have developed our own setup here also to simulate this flow in the laboratory condition. So we have a very long snowsuit, about 65-meter long, in which we can release about 10 to 12 cubic meter snow mass, and we can obtain the velocity in snowsuit 10 to 12 meter per second, which is very close to the Froude number, because in the gravity flow you have the Froude number which determines the characteristics of the flow parameters, sir. So we have in this snowsuit we can obtain the Froude number up to 4 to 7 or 8, sir. And natural flow major avalanches has Froude number 7 to 12, sir. So in this condition we can create the avalanche artificially similar to the natural avalanches, and we can put various type of retarding structure, deflecting structure, and we find out how much runoff height it takes, so we can optimize the curvature and transition curve for the minimize the runoff height and smooth transition to the avalanche flow, sir. In these conditions, but one we are facing one of the problem in practical life, it is the thing that it is changing boundary condition problem, means all avalanches will not move with the similar velocities. Sometime any particular velocity, design velocity, you have designed a deflecting structure, but smaller avalanches will come, then it will reduce the effectiveness of the height. And so in that condition, you have to design and optimize the height of the deflecting structure reasonable so that it can accommodate 2 to 3 avalanches in frequent degree paths. So effectiveness of the retarding structure cannot be scientifically 100% can be done, but you have to understand the in basic thing is how much mass is coming from top. It is very important because always avalanche will not move the in similar condition. Means sometime half meter slope will fracture. It will stop at 15-degree slope. It will change the terrain, and then you have a major avalanche activity. Then the effectiveness will be less. That is the main problem, sir. So any expert designer should understand how much mass will come down. It is very important, sir. So this part goes to the diversionary and deflecting or retarding structure. But at the same time, we always propose for the highway planner. One thing I always say that how much formation zone area and how much line segment, means how much road length is affected. If this ratio of formation zone to road affected length is very small number, then you go for the supporting structure and it will give a very good solution. But this ratio is very high, then you go gallery like structure, because formation zone structure would be very, very costly for us. In highway planner, it is very important and very. So these are the parameters, sir, and we have designed many structures, sir. In Gulmarg, we have designed a very Alfred, it is 4,000-meter height. For the J&K government, we have designed a diversionary structure, 160-meter long, with the collaboration right by the consultant from there, but it is completely designed by staff and implemented, and it is functioning from last 10 to 15 years. And we have in defense application many structure. We would not like to discuss those in detail here.
Okay.
Okay, so
Yeah.
before we move on, I would like to take this opportunity to thank our sponsor, Geobrugg India Private Limited. They are the world leaders in providing protection solutions against natural hazards like slope instability, rockfall, debris flow, avalanche, shallow landslides, etc. And we have Nadine representing Geobrugg here today. Nadine, I believe there is a presentation that you would like us to go through.
Okay, thank you. So thank you that I can be here and that I have the opportunity to do a little short presentation. I think it's just like good to know that we are all talking about the same. So I like to start with some basics about avalanches. So as we already heard, yes, you need a lot of mass that is coming down a slope that the avalanche occurs, and that also can contain rocks, soil, vegetation, or ice parts. For example, here is one at the highway infrastructure in Norway. And what the goal is that we can prevent or build some structure that this infrastructure down here is safe. Okay, so important for the construction, or depending on what kind of structure you like to build, is that we understand that we have that fracture zone. Let's say it's called also starting zone. So here the avalanche starts, and we usually have a slope angle of 30 to 50 degree. At least we need 30 degree that it can be started. So, and then we have that path, that transition zone, that can be a sheet, or as in that picture, like a gully. And then we have that deposition or run out zone where it halts, and that needs also to be at a less slope angle, or as we already heard, it can have a run up height if you meet a counter slope. So when we are talking about the avalanches, we have to be aware where they can occur. So as I mentioned, we have the 30 to 50 degree. We need at least 30 degree that something can move or start. And why is that avalanche even moving or starting? So what are the triggering effects? So we need, of course, first we need precipitation. We have snow there, and most of the time wind is let's call, or we at least in Switzerland say, with precipitation and wind we are building the avalanche, because you have a lot of snow at one part, and we need, in that snow cover, we need that kind of unstable layer. We call it a weak layer, and on that weak layer we have another part of snow cover on top, and then that weak layer can just release by itself because of the weight, or we have additional, for example, here we have skiers or even explosive for animals, or just a rock fall that is hitting the snow cover. And also a key factor for triggering effects are these temperatures. So we see that in summer, or actually in springtime, when the snow gets really wet and heavy, they are just triggering by themselves. And then also important for the understanding of the avalanches are this classification. So we have these two type of release classifications. We have that large slab, as you can see here. So that is actually here that weak layer, and there it snowed again. So we have that snow cover on top, and we had here the skiers that triggered that avalanche on that weak layer, and we have the kind of sheet that started to move. Or then we have that loose snow or punctual start of avalanches. And then it is really important also for the simulation of the flow, as we already heard. It depends a bit on the motion, what kind of avalanche do we have. If we have one with a lot of air in there, so a dry avalanche, or if we have, as in springtime, or when it's really warm, we have that kind of dense, wet avalanche. So it's not, the behavior of the motion is not the same. And then there is also a huge difference between if the avalanche starts as here on one of the weak layers, so we have still a lot of snow to the ground, or if we have the so-called ground avalanches and it really released on the ground. So at least in Switzerland, we can see that a lot when it's warm and in spring, so that basically the entire snow cover started to release when we have these wet avalanches. And like all of that are different kind of avalanches, and for that we don't have like one measure for mitigation. So it is important that we know with what kind of process we are really dealing at a different site. And here I just have a short overview of possibilities. So we have that starting and accumulation zone on top here, and then we have that tracking zone, transition zone, and then down here we have the run out zone. So and in this case we have kind of everything in here. So we have that.
Okay, what we can do is I believe we can continue with the session until Nadine figures out how to sort the speaker situation. Dr. Singh, can you continue with the questions, please?
Okay, the very general question, but I think it is a very fruitful to understand these basic things related to the avalanche. So I am putting to all the panelists, not to specific to anyone, what are the various factors that can trigger an avalanche? So I should request first Dr. Kumar. Uh,
The basic thing is, sir, avalanche is the slope, sir, and slope between 20 to 50 degree is the resistance and of the avalanche, sir. If you have a larger slope more than 50 degree, then there will be continuous and snow will disturb, so accumulation is not possible, sir.
Can I
And
request
second
everyone to
parameter,
mute themselves while on stage so we can hear Dr. Kumar clearly? Thank
second
you.
parameter is the which is very important. That is the how the snowpack has been built up. So basically, snowpack characteristics means you have before occurrence of avalanche generally 3 to 10 different scale has been already occurred. So you have various layer of snowpack. So in those snowpack, where is the weak layer? If the weak layer is lying close to the ground, then you have more mass can come down. So if you have a weak layer at the top, then it's more direct action avalanche can come, but if it will come, then quantity will be lesser. So second is how the snowpack has been built up, and this snowpack characteristic is divided into 10 different categories. So what category snowpack of that condition in that particular day exist, because you may have three spell you have received, means three different snowfall, means one means 24-hour seizure of the avalanche. After again, if avalanche, sorry, after 24 hours, if next snowfall will occur, then it will consider as next pack, sir, snowpack, because it is a continuous formation. So snowpack characteristics is the second important, and third, which is very very important, snowfall intensity and in last 3 days. That is very important. So these are the major parameter, but of course other parameter is the curvature of the terrain, because it will decide the frequency of the system, and you have also temperature, some minor effect maybe, but they are less effect. It means three fundamental parameter is here, sir. One is the snowpack, how the snowpack has been built up, and how second is last 3 days precipitation pattern, how it is snowfall is going occur, or it may be sometime 24 hours also very important if intensity is very high. And third is the terrain, sir. These are the major parameter, but we have wind is very important parameter, sir. because wind can redistribute the snowpack and it can deposit in the unstable zone of the formation zone. Then
Hello?
sometimes you have a snowfall very thin, but accumulation of snow due to wind drift in
Yeah.
particular is very high. Then in that condition also avalanche occur. And these wind effect is
Let's go.
sometimes is very predominant, and people sometimes underestimate it, sir.
Yeah, sir, and I would like to add the certain more parameters like vibration, for example. Maybe it could be due to earthquakes, it could be due to any construction
Yeah.
activity like tunneling. Even sometimes, like moving animals or passing plane can trigger an avalanche. So it's there are multiple factors which can trigger an avalanche.
Exactly. These factors are the contributory factor of the existing systems.
Right.
And sir,
Nadine, are you back? Professor Singh, you're on mute.
So, Rudra, can you highlight some of the things which is related to the ice fall? Because the same parameter cannot be affecting this ice fall.
Well, ice fall is having a different, as you said, like it's totally
Well, this is
different.
a part of avalanches, but so
Yes, it's a different
that part
phenomenon.
we are missing. So, little bit some contributory factor or triggering factor related to this ice fall.
Yeah, if it is specifically ice, the main triggering factor which can trigger a detachment of an ice will need to be much more substantial. So the rise in temperature surely will be one which can trigger a separation in a pack of ice which is deposited or formed over a period of time when the snow gets deposited. So ice will generally
Hörst du
be in
mich?
the lower layers
Nein, es geht nicht.
compressed.
Hello?
Hi, Nadine. I think
Okay.
we can hear you now. Rudra was
Oh,
just
sorry.
telling us about ice fall. Okay. Rudra, I think you can continue.
Okay.
I can
So yeah,
continue.
that
Okay, sorry.
Rudra, you can continue after that.
sure. So that is one important factor, and then something which can trigger a separation in the ice sheet would be a big vibration. It could be due to any type of vibration, be it construction related, be it earthquake related.
My next question is to Mr. Rudra. Are you currently executing any avalanche protection project in India? And what are the challenges uh, you are facing on that place? And what type of system you are going to use or you are already using it? So that if you can highlight some of these points in very brief, uh, then it will be good for this attendee to understand this.
Sure, I'll do that. So, to start with the first question, so yes, we are currently executing avalanche mitigation projects in Rohtang at 5 different locations, basically towards the approach of the south tunnel portal, the Atal tunnel portal. So there, the protection measures that we are providing are basically to treat the formation zone. So we are trying to mitigate the risk of an avalanche to form altogether. So we want to prevent the occurrence of an avalanche. So that is the aim of the treatment that we have started, doing the execution on that site. In terms of the challenges, well, the biggest challenge always is the construction part. So, and specifically in the construction, when we are treating the formation zone, the biggest challenge will be to first of all, shift all the material to the formation zone. And the next one, of course, will be the daily movements of all the the people who need to work on the slope. So those two are the biggest challenges, apart from the high altitude and weather issues that are always there, at such locations. In terms of the systems that we are using, so here we are using a flexible system of umbrella type units. So basically, they are made of heavily galvanized steel elements. I'll just try to show it to you very quickly, what I'm talking about. Let me know as soon as you are able to see it. I hope you are able to see the screen.
Yes, your screen is visible.
Okay, perfect. So this is the snow umbrella system. Basically, it is comprising of different elements, starting with the main steel beams. This is the cross beam, the facing element, which is comprising of the belt. We have the reinforcement stem. We have the steel tie ropes connecting the stem and the fascia elements, and of course, there is the main anchor at the back. Uh, in addition to this, there is a special arrangement at the front. Basically, it's a counterpole arrangement which is provided near the nose, and there is a slider leg as well on both the both the bottom ends. So these legs allow the units to align itself as per the pressure orientation from the snow which will get deposited at the back. So these are the units that we are using at all the 5 locations.
What will be the tensile strength of your wire?
The wire ropes are basically graded at this 79 Newton per mm square. So these are of course the high strength wire ropes that are being used. Even the steel is high strength steel, which is heavily galvanized, and also suitable for the low temperature conditions. Otherwise, if it's a regular steel, it tends to become brittle with low temperatures.
Okay, can you have some creep type of study related to these wires? Some
Uh,
creep study has been conducted because it is a continuous loading is going on if it is a continuous flow of.
Right. So these systems basically are tested on field. They are installed on the field, and what is done is like they need to sustain at least one season for it to pass the test. So that has been done for these systems. So it has the technical approval done in Italy. As far as the creep with respect to the loading which is going to come, so those do get accounted in the design itself, not just of the materials but in terms of even the pressure calculation, because when we do the design, there are different snow factors which we have to take into account, like the glide factor, the creep factor, the altitude factor, things like that. So the creep factor is also getting inbuilt when we calculate the snow pressure on the system.
Okay, is there any possibility to go for the presentation once again, or still not?
Nadine,
I think so. It's working now.
yes. We
Yes,
can.
fine. Welcome.
Thank you.
Please continue.
So you already see my screen?
Yes, it is showing.
Perfect. Yeah, I guess, was that the last slide you saw, or you heard something?
I think this is where we were.
Okay, perfect. So I went on with possible mitigation measures. So as we said, yeah, we have here like the accumulation and starting zone on top, and there we can build in some possible mitigation measures. So as you can see, for example, the snow nets or snow bridges, and then we have the tracks and the runout zone. And also, if you have something on the track or that transition zone, for example, we have there that road. we can have that tunnel, and you also can see that on the right picture down here. I don't know, I don't have a pointer at the moment, but I think you can see it. And then we have some measures we can install in the runout zone, for example, like as you also can see, like the dams there, or if you don't have that many houses there, that you can resettle the houses already, that you have enough space and area for the runout zone. So there is a couple of possibilities for measures, and it basically depends a bit on where your location is and what your process is and what you like to prevent. So I just summarized that here a bit. You have the technical measures, as I said, like all the measures in the starting zone, like the tunnels, deflection structures. And you also have, for example, if you have houses there, you can protect the object, so the houses a bit more with measures. And then we have that biological measures. I mean, at least here where we have still the forest boundary pretty high, so we can use the forest to protect it from the avalanche. As you also can see here, we have that tunnel and that gallery, and then we have still the trees. So we use them quite a lot, or at least as help if we have them. Maybe not so for India. And then we also have that or other systems, for example, like the warning systems, or that you can artificially trigger them. So in that case, we have mobile explosive stations, or you can try to explode them from the bottom valley or by helicopter. And of course, yeah, then you have to evacuate and closure roads. And what is not really working in Switzerland, for example, is spatial planning measures, so that you really resettle people. So in our case, that is not really working. We only have like restrictions at the moment where you're not allowed to build houses anymore, where it is dangerous. So that is kind of like a really a rough overview of possibilities you can use in case of avalanche problems, like just general ones if you want to go for technical measures, or like it's, as I don't know what you were already talking about, so I had a gap, but it's like you need to take in account a lot of different things, and it's not only that you can install like technical measures, it's kind of a combination if you have technical measures, for example, with a warning system together. And then just as I said, that supporting structures in the starting zone. So that is really, really important to know. They are only for the starting zone. So you install them in the starting zone. And we have the snow bridge, so that ridge supporting structures. And we have these flexible supporting structures, the snow net. And for example, here we already had one in India. So that is a flexible one. It's a snow net, as you can see. So basically we have the net, we have posts, and we have ropes and anchors. And it already started, a long time ago. So they first installed them even with wood together in a combination, and now it developed up to that so-called spider avalanche systems, the one you can see on the right-hand side. And just that you get an impression how that should work. So as you can see here in the left side picture, we have that starting zone, and we have a lot of structures in there. And actually you use that structures that in between there is no possibility to start an avalanche. So basically you build in obstacle that should stop the avalanches. And that you can see really well. So on the left side, there are a lot of structures in there. And on the right side, there is no structure. And there we had that slab that I explained before. And yes, on the right side, you see one of that possible flexible structure you can use. Important is if you like to install something like that, there is an arrangement of the barriers. So you can have like that continuous structures. Basically, you really have a closed line, or you can have interrupted structures. and it really depends a bit on the terrain you have, so and what really is occurring there. So basically you can have one of that also combined structures. As you can see here, we have some long lines and then we have shorter ones in between. And all of that, how you should arrange that and what are the gaps in between. So if the gaps between the structures are too large, so you should be aware of that something is starting again. So all of that is defined in the guideline from defense structure in avalanche starting zone from Switzerland. So, and that is basically worldwide applied. And all the construction here in Switzerland are built according that guideline. So here is a top view of one of a good example. So you can see that we have these different lines and gaps in between. So for how it looks like with a net solution, as I mentioned, we have the post, we have a net, and we have ropes and anchors. So basically, it's pretty simple and fast for installation. These are possibilities for anchoring of the post, and there is something like the pressure post. That is pressure post plate is you can put them on loose soil and you don't have to directly anchor it with a micro pile as the ones on the left side. And this pressure plate is also well, because if you have a creeping soil, it creeps with you, so it creeps with the system. And here again, some examples from Spain and Italy. So they get installed everywhere where we have avalanches. And as I already mentioned, we have that Swiss guideline. So actually in Switzerland, you can't install something else that is not according to that guideline. And the guideline basically tells you what kind of static proof and calculation proofs you need for your system. And then, as already mentioned with the umbrella system, it also has to be installed in the field. So for 1 year or even more. And then they decide on if they approve the system for certification, and only when it's certified you can install it here. Right. So this is just like a rough overview of what kind of systems we have, and the systems, they are mostly categorized in snow cover thickness. So that is a key factor, and as already heard, the gliding factor too. Yeah, so just for like short, what are the benefits of such an installation? So it's pretty light. You can fly up them by helicopter, and in that case, it's also tested with rockfall. So that is a big difference between the ridge system. So if you have a rockfall, they don't deal that well with it because they are so fixed and not like a net or a flexible system, so they can handle rockfalls better. And then, as I said, we have that pressure plates that helps a lot for installation. And yes, what else? Yeah, you don't have bushfires, I guess, but it's also good with fires. And of course, the corrosion protection. And that is a picture that you can see how it looks like. So you can build everything on a smooth place together, and then you can hang them up on the helicopter and fly them on site. You also can do like a combination. So we have the ridged ones and we have the flexible ones in between. Yeah, just depending. And as I mentioned, the rockfall is always a problem. So in that case, if you have more than one row, it is also possible that one row get hit by the rock that much that it's not useful anymore, but it's getting stopped in the second or in the third row. and regarding the rockfall, it's always a question of what is the major hazard you want to prevent. So in case of avalanches, it's obviously avalanches, and if there could be a bit of rockfall, yeah, you could install one, but it's obviously not the major hazard. If you want to withstand rockfall, then you should better go for a rockfall barrier. Yeah, so this is just a image of the pressure plate. So that is also helpful because you don't have to drill that many anchors, but it really depends a bit on the ground condition. Right. So as I said, the structure developed over time. So on the right-hand side, you can see that really continuous and closed mesh. And on the left-hand side, you see like the previous construction there. It still has these gaps in between, but both of the system are still working, and both are getting installed quite a lot everywhere. And yeah, obviously there are also other systems, and it is just or for the understanding what kind of system you should choose or what is important. There is not only the static component, there is also this part of dynamic. So if you just have static loading because of snowfall, there is also that creeping factor, or just like the creeping motion of the wet snow in the springtime. And a barrier obviously is designed either for static or dynamic. So to do the right combination about it, that is pretty difficult. And yeah, but we managed it over these last 40 years pretty well. As I said, also fire, since it's steel, shouldn't be a problem. Regarding corrosion, it is not, at least the corrosion topic is not, let's say, not that important as for other products, because you're high up, so your corrosion level is not so high. And even here in Switzerland, there is no specific corrosion protection needed for avalanche structures. So or at least the guideline tells us that you should have an allowance of more or a larger diameter that it can be or get corroded a bit, but it's not like for other products. As long as you're not close to the sea, for example, in Norway, where you're really close to the sea with the avalanches, there you should take an eye on the corrosion. Yeah, this just like the corrosion part, I will skip a bit. And we'll show you some of them. They are since the 1980s, so that's 40 years now, and they are still looking quite well, so almost as new. Oh, sorry. So just that you get an impression how they look like, or they have different, for example, the height, the barrier type, so that is 3 meter now. And then we have that different kind of gliding factor. So basically, for the guideline, that is telling us, yeah, we can go for 2.5 or 3.2. So that is a difference in the how your terrain looks like. So, and basically they are certified for that that standard parameters the guideline is telling us. And here we have a total line of 64 meters. And here you can see how the installation is going. That is from the top view. Another one, so this one is already quite long. I mean, actually it's not in one, so it's just like the total one. So every single field together are summed up to 455 meters. Yeah, so that is just like the overall scope.
Okay.
You get, so basically you have everything here. And I guess we are talking also a bit more for the question and answer about the avalanche
Mhm.
systems.
Okay,
Perfect.
so I think we can continue with the questions now, and we can take this discussion forward. Professor Singh, would you
Yeah.
like to take over?
Yes. Two quick question, ma'am, and we like to have a short answer because we have the next session also. So, what are the risk assessment technique to propose an avalanche protection system on a particular site?
Okay, so what we are doing, or it's called, like, I don't know if you know it, internal risk management. So basically it is out of the risk analysis, risk assessment, and then action of planning. So basically at the risk analysis, you ask yourself, or at the site, what could happen? So for example, is there avalanche, is there rockfall, or whatever? And at the risk assessment, it is the question kind of what is likely to happen, and there it's already getting what is underneath. So is it houses, is it people's life, is it traffic? And then you have that third stage where you do your action planning. So what must be done for that case, or what your extreme scenarios, kind of what you like to protect. And on site, an example for the avalanche protection, it is really, you have to understand what your process is. So from the terrain, do you have like the avalanche coming down in a gully? What is on top? So you like to prevent it in the starting zone. So it is not that if you have if you're, let's say, you have one starting zone that is totally on the top, and then you build in there the construction, then you have further downstream, you have kind of um, this second starting zone, and then they're coming together questions. Okay, is that enough on top you have for the installation? And you agree, or you say, okay, we allow a little part of the avalanche coming down, and we prevent that with a dam or deflection dam or whatever in the transition zone. So that are the questions you have in that, what must be done in that entire combination. And important is also that you have this, we call that return period of the event. So if you have it every 30 years, that event, or is it coming every 10 years? So it's also in the risk analysis, actually, and what you're allowed to happen, basically. And really important for snow is that you know the snow conditions, so the snow height, and that you know also how your wind is occurring. So basically, if you just have, or if you measure, we have, let's say, 3 meters of snow height, but you have all the time a lot of snow. So basically, a lot of wind. And then basically your wind can accumulate all the snow on one part, and then you underestimate your snow height. So this is really that you understand what is happening actually on your side, that you can do the best protection or estimate the best protection.
Okay, another question, ma'am. You have proposed many types of this protection system on the various locations.
Mm-hmm.
What are the basic parameters one can use to choose a particular system? Whether I can go for the snow racks or the snow bridge or umbrella, and moreover, whatever you have planned. So, what are the basic things which one should care while using such kind of protection measure at a particular site or a specific site?
So you have to take into account the local snow and like the terrain, how, if it's like you have that gully or that shaped one, and what are the ground conditions. For example, if you have rock or loose snow for drilling, because as you saw, the snow bridge, for example, they need 4 anchors, or they even have a foundation with concrete, and that are measures you have to decide on. And then with the snow bridges or snow rigs, you just have no, for rockfall, it is pretty bad. And then it is just like all the snow net are less sensitive to creep movement. So that is also a large amount. So that's really advantage of that snow nets, because they can move, they are flexible. And like if you have that snow bridge that is just like, yeah, it's rich. So if you have that dynamic part that is acting, so that is, yeah, not probably not the best choice. And then, for example, for umbrella systems, in Switzerland, they are not allowed to install because they only have one anchor. And if you have a failure of one anchor, your entire system failed. So you don't have a kind of backup there. Yeah, so that are the parameters you should take into account when you decide on your system.
Where the supporting plane in umbrella structure is perpendicular, and supporting plane in your snow net, generally it is in the umbrella structure it is vertical, and in your snow net it is perpendicular, near to the perpendicular. So what you think the supporting plane through which we can restand the snow I put the snow in compression, it should be vertical or perpendicular to the terrain, because umbrella structure has it is used vertical, totally vertical. And secondly, umbrella structure does not allow any resistance against the rotation. So if two umbrella structure, due to resultant force in various opposite direction, they get separated from each other by certain distance. So how these can be considered, that is very important part in complex terrain, because the path is not wide inclined plane, it is curved one, means it is like a gully, like a ball shape. So resultant force from both sides of the umbrella may not be in one direction. Resultant is not in the along with the main solid member of your umbrella. It may be it has certain rotation in particular direction. So how it will restand?
I'm not really the umbrella specialist.
I'll take the question.
Okay.
Dr. Kumar, in the umbrella structure, well, yes, there is a limit to the rotation. It is not like, it's free to move throughout. There is a rotation allowed of around 10 to 15 degrees, not more. The this allowance is given so that it can properly align itself to the pressure when it is half filled, three quarters filled, or fully filled. Once it is fully filled, automatically the structure will be coming perpendicular to the slope because there is the load acting. When it is completely unfilled, like say for example how it will be now, because there is no snow deposition, so then it may appear to be vertical, but once it gets the pressure, it will align itself perpendicular to the pressure. So there is, as I said, there is a limitation of that movement.
My question is very simple. If you allow 10 to 15 degree to rotate and your center point is 6 to 7 meter, and 10 degree rotation will separate two structure by a certain distance.
Yes,
So that gap is maybe very dangerous.
right. So in terms of separation, see, if we even if we refer to the space gathering, such integrated structures are spaced at a spacing of around 5 meters from each other. And in terms of the rotation, so basically, the full line will function because the pressure, the snow deposition will happen, the pressure on all the units will be there. So, it will tend to be aligned in a similar plane unless there is a large undulation. So, and the unique part of the umbrella system is that it can adapt to the large undulation because those are individual units. Because if we have to go for snow nets, we also offer as a Maccaferri company, we also offer the snow nets. But then for the undulating terrain, it's very difficult to install a snow net, which is a continuous structure. So actually, because of its nature of individual unit.
Just I want one question, yes or no. In complex terrain, where gully type, ball type of terrain is, you don't think that your umbrella structure will be quite less effective in comparison of snow net? Because you are putting first, it is a vertical one, so effective plane means it will 4 meter structure will correspond to 3 meter snow net height structure or 2.5 meters depending on the floor. So you think that in complex terrain, your umbrella structure effectiveness to support the flow means convert it in compressive stress to support the flow in the other side is less effective than snow net or not?
No, it is not like that, sir, because if we take an example of the height, okay, the decay value. So the decay value, if we take that and if we take also the plane of the snow umbrella, the height of the snow umbrella unit is actually more than the decay value. Okay. So once, as I said, like once the snow deposition happens, it becomes perpendicular to the plane and it matches the snow depth properly. There won't be an issue of it being of lower height because it is designed for that particular decay value, which is particular.
Okay, Rudra. Rudra, I think Dr. Kumar, every system has certain limitations, and this our ground is so unpredictable that one cannot say that whatever they are providing that will be the 100% foolproof and risk proof. So in nature we have the always uncertainty. We said move out
There's
of
always
that,
a
and
factor of safety to be applied.
again I have a small question from Dr. Kumar, that this recently this Atal tunnel is passing through this various avalanche zone. Can you explain that your organization has contributed something on that, and what are these means if you have employed something, what are the rationality behind it?
Sir, actually, sir, from last 30 years, means we are working for this tunnel, sir. Means basically, major problem was to give the solution to the approach road to the tunnel. If you take the Rohtang tunnel, sir, the approach road from means if you take from the Solang Nala, it is about 8 to 10 kilometer distance, sir, and we have about 13 avalanche paths, sir. So from last 30 years, we are measuring the snow, avalanche affected road length with the GPS continuously. We are monitoring the extreme avalanches. We have standardized the major avalanche path to the approach tunnel, sir, in which we have one very major avalanche site, which is called we call it Saitani Nala, we call it the MSP7 avalanche site, sir. We call it Findri Nala, sir. And this Findri Nala avalanche path has glaciated region at the top, and total catchment area is about 10 square kilometers, sir. And it has very high flood, very high debris flow, and we have more than million cubic meter, more than million cubic debris measured by my team, in which I was also there with scanner or survey instruments, and flow depth or deposition height is more than 8 to 10 meters. So we have given the complete solution for this MSP7 site, and we have designed the gallery there, and we have patented it a geohazard gallery, and it is patented in the name of our department, sir. And because it has allowed to pass the million of cubic meter of debris also, sir, during, because it was designed in such a way that we have put box type of structure with fins, ring of the concrete ring all around at in box structure, and this ring is connected with the counterfort retaining wall, and we have uphill side, we have a inclined wall also. So all the impact pressure it can sustain. But after the construction, sir, after complete construction, the nala which was just I want to share this, which was 9 meter below the road level, nala was deep 9 meter, and length of this nala was more than 70 meter. After major debris flow and rock, or what you can call it, debris flow basically, then that after construction nala height raised by about from the road level it is 9 meters, and whole mass is retained in upstream side, but it has been designed in such a way that it has sustained all the load, and it has proved that in the connecting road from Manali to Leh, our organization DGRE can give the complete solution to any most vulnerable site, sir, and it is effectively functioning, sir. So currently we have completed up to the Rohtang tunnel, but later stage we are designing the control structure for the forward area in planning part, and that will be done by our department, sir.
Professor Singh, you're on mute.
There is a major problem of sinking of ground. Is there anything related to the snow to this sinking of this ground in that area?
Sir, thinking of the area for that problem, we have given the raft foundation because we have made the drill more than 50-meter drop down, and this nala was initially glaciated regions. We have not found any rock till 70-meter deep from the bed level. So we have put in the gallery raft foundation with the fins, and we have cross beams, so that whole gallery can be, even the sinking area is 30%, but load will be distributed throughout the gallery of 120 meter, and uniform settlement may be allowed. So sinking effect can be minimized, and due to some sinking there will be no structural damage, because if your sinking is the complete structure by few centimeter, it will not affect the performance of structure. Only differential sinking will affect the effectiveness of control structure.
Thank you. Thank you. Next question is from Mr. Rudra. How do you decide on layout and configuration of snow supporting a structure in the formation zone?
Okay.
Rudra, please.
Yes. So basically, this decision of the layout and configuration of snow supporting structures in the formation zone, it is decided based on the Swiss guideline, which is the defense structures in avalanche starting zones, which Nadine was mentioning about. So there are multiple factors that govern this layout and configuration. Let's say, the functional design of such systems. So these factors are basically, dependent on, first of all, the snow inclination, because the most conducive range, which is 30-degree to 50-degree inclination, that is the range of the inclination of the slope and the zone of the slope that we want to target with respect to stabilizing the snowpack in that zone. So just let me share a couple of slides to show a few things to you. I hope you are able to see my screen.
Yes, please.
Okay, thank you. So as I was mentioning, first and foremost is the slope inclination that we have to see, and then accordingly place the supporting system in that zone. The next one, of course, we have to also decide, okay, what should be the first starting line, the topmost line in this section that we have to fix. So typically, this is fixed at a distance of around 2 to 3 meters, the height of snow deposition. So 2 to 3 times the height of deposition of snow from the observed or anticipated fracture line of an avalanche. So that is the first line. That's how we have to fix. if there are, there are certain zones along the slope, if the slope is very long, and then there are also secondary starting zones. So again, we have to take that into consideration and fix the topmost line for that zone accordingly. With respect to the lowermost lines, for example, if this is the lowermost line, so the lowermost line should be fixed in such a way that the slope inclination below it drops to less than 30 degrees, so that the avalanche doesn't happen, and there should not be any damage which can arise from an avalanche triggered in that zone. So that's how we fix the bottommost line or the lowermost line. So once we have the uppermost and lowermost line, we now have to also fix the intermediate lines and what should be the spacing and things like that. So let's see. And with respect to the alignment in relation to the snow pressure line, so the alignment of these structures along the length should be normal to the anticipated direction of the snow pressure. So if there are basically, we have to follow the contours in the plan drawing, so that the anticipated pressure direction is remaining normal. As far as the lateral extent is concerned, so how long should be those lines? So the lateral extent should be wide enough to cover the entire natural terrain, so that ideally, if there is certain terrain ribs or boundaries existing, so it should be extended up to that. In case like they need to be terminated in an open terrain, so naturally the end part need to be reinforced. So this kind of an arrangement is like is the same for whether it is a snow net or an umbrella system. It's just that with the umbrella system there will be the 0.5 meter gaps between the individual units, so it's called the separated or the interrupted structure. When we come to the spacing between the rows, so the Swiss guideline also incorporates the procedure to fix it, and they have given some equations, and they've also given tables for the most likely conditions that we encounter during the design. So the design of the spacing is dependent on the inclination of the slope first and foremost, the height of the snow deposition. It is also dependent on the glide factor. So this n value, the glide factor, is dependent again on the roughness of the terrain and the configuration of the slope. Apart from that, there is also a dependency on what is the roughness between the snow and the terrain. So again, there are different ranges given, and then we have tables available for different slope inclinations. So we can use these tables, we can use the equation from which this table are formulated. We can do some interpolation if required, if there is a variation. So this is how we do the functional design.
Okay, thank you, Rudra. The next question, just I want to put to Nadine. What codes are followed for designing the avalanche structure in formation zones? Eurocode or national standard in Austria, Germany, or Switzerland?
So basically everything what is in the guideline is based on the Swiss code. And the Swiss code is pretty similar to the Eurocode. So
the next question with Dr. Kumar. What is the reason that there are not enough project reference for the avalanche protection in India?
Okay. In initial stage, most of the highway which is going to the forward area like Leh and other places, it remain closed for 5 to 6 months, sir. And until and unless we make it the plan it that it will be operational due to winter, putting in isolation control structure was not very economical thinking. Now government is planning to open the road to the Leh area, up to Leh area. The importance of control structure comes, sir. As far as the recreation and winter sports is concerned, we have few sites which are affected by the avalanche. One of the J&K government Gulmarg Gondola for which this establishment DGRE has contributed and given the complete protection scheme. Because if we see the Gulmarg gondola, it is one of the international standard for ski sports, sir. And we have given the complete design assistance and it has been implemented, sir. But the winter tourism and adventure in the skiing in the snowbound area is not a very, it has not seen as one of economical aspect for the country from where the government of India can generate lot of revenue. So in that pattern, if we make it as a winter sports and events, then in that condition it can be developed, sir. Third thing is that the population in most of the avalanche prone region is very thinly populated area, sir. So government has not put much, means we will have not made the many structure in the avalanche prone region, sir. But now,
thank you.
if it will come, it will certainly make a boost to the tourism.
There is a need to boost up and make more references to people should know and aware about this. Rudra, I have a question from you. What is the maximum snow depth that snow nets and umbrella system can be designed for? And what is the maximum load bearing capacity of these nets? Please be brief because already you have spoken something about this umbrella system. Please. Yes.
Right. So, with respect to the maximum snow depths for such snow nets or umbrella units, so typically, the snow depths range from 3 meters to 4 meters. 4 meters is usually what we most encounter as a higher limit. But we can always go for higher height structures, which can be specifically designed based on requirements. We already have. We can treat the snow depths up to 4.5 meters. But as I said, we can have higher height structures to specifically design to be specifically designed based on the actual requirement if there is anything further, but typically 3 to 4 meters is the range. With respect, sir,
one suggestion from my side: 4 meter is ideal structure for snow net. For umbrella structure, because this structure is vertical one, so its component along the perpendicular plane, it will come only 30 to 40%. So effective height 4 meter snow net, it is correct, but umbrella 4 meter umbrella structure has effective height is only 2.7 or 2.8 meter, 30 degree or 45 degrees slope.
again, well, sir, we always design for the decay value, and the decay value is dependent on the how we calculate based on the snow depth, and the umbrella systems again are checked for that because the umbrella system, okay, for snow depth or say decay value of 4 meters, the actual umbrella system is a little higher. The height is higher, so it takes into account that part. And since as I said, there is a special connection which is a ball joint connection which allows it to have certain degree of rotation. So once the structure is loaded, it becomes perpendicular and it matches the decay value. And of course, there is also a little bit of the freeboard. And with respect to the other part of the question, which is talking about the load bearing capacity. So basically, that is dependent on the snow depth and the pressure which is getting exerted on it. So that varies depending on whether that pressure is acting in the central part or whether it is towards the end, because end always has a very high pressure value when we do the calculation. So that could be in the range of around, typically that could be in the range of around 35, 20 to 25 kilonewton per meter square in the central zone, and it can reach to, maybe 2-3 times value towards the end zones because of the additional pressure at the ends.
Thank you, Rudra. With this, we have completed our session first, and I can now give a chance to host to take care of other things.
Okay, so what we're going to do is we can take a short break. where the audience is, they can mingle and network amongst each other, and we all can go backstage. Okay. So we'll be back shortly, everyone. Welcome back, everyone. Thank you for staying tuned with us. Professor Singh will just start the second session of this discussion.
Thank you, madam. In second session, I will speak my learned speakers to don't repeat it what you have said earlier. If anything is contributed, it will be okay. Otherwise, if already you have said something, just say that already the answer is given, because maybe I am a repetitive in some of these questions. So bear with me, and we have already exceeded our time limit, so better we should be very brief. So first I will start this first question from this Nadine, that ma'am, what are the input data that is required to design an effective system for avalanche prevention?
I given already the answer, but I'm short. So you need snow cover thickness, gliding factor, slope inclination, and density of snow.
Thank you, ma'am. Dr. Kumar, it says involved in the construction of Johila Tunnel approach road to the tunnel passes through several active avalanche zones. And what type of system is being proposed by your organization?
So for this, we have given in the major site, we have put a tunnel, and to reach the tunnel location, we have in this site put the snow gallery at various location in form of box structures, so that closed passage can be allowed, because in those areas supporting structure because very difficult, because terrain is very large and formation zone area height is very large, means very high, means it is not feasible to stop the avalanche. So better to effectively pass over the snow gallery most of places, but few places we have put elevated structure to underpass the avalanches.
Thank you very much.
Or deep
The
valley.
next, yeah. So next question will be from Mr. Rudra. Rudra, what are the defense structure against avalanche in middle zone or run out zone? And what type of dimension system or software that you are using to designing such protection structures in the formation zone?
Um, okay, I'll just quickly again once more show it to you so that I can be very brief in explaining.
Yeah.
I'll use the already available slide. Yeah, okay. So when it comes to the sliding zone, which is the the intermediate zone, so there the deflection structures work, and the purpose of such deflection structure is basically to guide or divert or restrict the lateral extent of the avalanche, which is already in motion, because the formation zone, the avalanche has already started. So in the intermediate zone or the sliding zone, it's everything is moving. So these structures need to be very massive in nature to withstand such a moving impact. So some of the structures, like the snow gallery, which Dr. Kumar was mentioning about, so that is one of the good solutions that can be adopted in the sliding zone. Other ones are like the guide walls or the avalanche ramps, like here. Basically, they allow the avalanche, the full avalanche, move out and away from the infrastructure, which can be protected. So it's kind of a roof, basically. And then there are also some diversion dams to restrict the lateral extent. If there are transmission towers, we can have a masonry wall forming a wedge so that the avalanche can be deflected. While we come to the runout zone, which is the bottommost zone, so the braking structures here play the main role. And again, since they need to break the movement of the flow, these need to be very massive in construction to basically train the avalanche mass. So the structures here could be in the form of masonry cast dams or retaining walls or wedges and mounts. The retaining walls can also be in the form of infosoil structures, wherein we need to have a very high structure with the limited space availability and relatively vertical face, because this vertical face is actually helping in stopping the avalanche to move further. Because if it's a sloping face like this, and if the avalanche is coming from this side, the avalanche will try to run over it. But if the avalanche is coming from this side of the face, of the vertical face, from the vertical face side, it will not allow it to easily over topple it. So such retention structures can be used. When it comes to the other part, like when we talk about the design of the formation zone, so I already explained, like we do the functional design from the Swiss guideline. But when we do the structural design, that is based on the we have an internal software based on the 3D finite element model.
I think Professor Singh dropped out because of internet issues. I will just wait for him to join back. Until then, we can continue the conversation. Um, Nadine, I'm going to direct this question to you. Although you already spoke about corrosion protection when you were presenting, how important is corrosion protection for various components of the protection systems, and how to ensure a longer life of these components?
Okay. As I already mentioned, also according to the Swiss guideline, corrosion is not really that important. So it is written that for the superstructure, there is not to be a corrosion resistant, or there is no need of an additional corrosion resistance. And that is just for the superstructure. So, but everything what is closer to the ground, there you should be aware of more corrosion possibility. And there we have that rust allowance of 2 millimeters at least. So you can go always a bit higher to be on the safe side. And since like everything on the corrosion is due to the corrosivity level and in the mountains, so that is not that high as you're close to the seaside. So if you're close to the seaside, you should take that into account. But in general, there is no special need or for the corrosion protection.
Okay, I think Professor Singh is trying to come online. Professor Singh, are you here? Okay, while we're waiting for him to join, we will continue with the conversation. So, my next question I will direct to you, Dr. Kumar. So, there are plans to install avalanche radars in Sikkim, which can sense the triggering of an avalanche and sound an alarm. Please let us know if this system is being designed and developed by your company, and what is the status of the project?
Yes, actually, this radar we are just in trial stage. We are putting in on experimental basis in Sikkim area, and after the installation and efficacy, it is perhaps it is not made in India. It is from abroad. We are taking it, but after getting its effectiveness, the indigenous similar system will be developed. At present, we are just measuring the effectiveness, means in advance how effectively it can give the warning, and we can close the passes so that no person should come in between the avalanche, because it can sustain, capture the movement from the top, and when the travel distance is more than kilometer distance, so we have enough time to save ourselves from the avalanche.
Nadine, I will direct the next question to you. Are there any systems available to periodically monitor an avalanche and inform the authorities in case of movement, which can protect precious lives?
Yes, so there are some monitoring systems. For example, in Switzerland, they have to close to the Matterhorn. You maybe know that the Intermat. So they have that detection system that in case there's something happening, so the gate is closing, so then it's closed.
Okay.
For example, I mean, here in Switzerland, GeoPrevent is dealing a lot with that monitoring part.
Okay. Rudra, I will. Okay, so construction of protective structures in the formation zone are always challenging due to accessibility. What is the best way to install these systems from the ease of construction point of view?
All right. So yeah, this aspect of construction feasibility, especially in the formation zone, when you are working in the
Hmm.
formation zone with very very high altitude at near the the crest of the mountain.
Hmm.
So this is of extreme significance, and just for the sake of everyone, I would also like to highlight that apart from just the accessibility, the available working period for the people to work based on
Hmm.
like not just on daily basis but as an overall project duration is also very limited because of there is a lot of time spent to reach that zone day on daily basis. There is a a very short working window
Hmm.
because of various climatic conditions as well. So that also needs to be factored in when we talk about the accessibility.
Hmm.
The construction, as such, the overall activity involves two main aspects. One is, of course, to shift the material from the base up to the top near the formation level, and also to prepare the necessary foundation and install the system. So, when we talk about the first part, which is the shifting of material from the base to the top, well, it can be done mechanically as well as manually. When we talk about mechanical systems, see, we can also do it with helicopters that we did for one of our projects in Saptasham. We got where we shifted the rockfall barrier using a helicopter there, which of course will be the quickest. But then there are also a lot of other external conditions which govern the usage of helicopters, especially in India. Say for example, the weather, the altitude. There are also the flying restrictions, depending on the location. Even the availability of experienced pilots who can do that kind of an operation is limited.
Hmm. Hmm.
So that is another part. And there is also the other option of doing a mechanical shifting by using a highline arrangement. I will try to show just quickly some photograph.
Okay.
I hope you're able to see this.
Yes.
Yeah. So
Just a request if everybody else can go on mute. Thank you.
yeah, so on the left you can see a photograph with the helicopter, using the underslung operation. So wherein the unit is transported fully assembled to that point where it is to be installed. And on the right we can see the highline arrangement, which is basically a system of wire ropes and tripod and winches, basically used to shift the material from the base to the formation zone. So these are some of the photographs of what we are doing in Rohtang. On the right, we are using the highline arrangement there to shift all the material.
Okay. Yeah.
Just to finish off quickly, so in terms of the best way to install, it really depends on location to location, climate to climate, site conditions to site conditions. Then the system which has the least weight and the least requirements of foundations and things like that will be easiest and quickest to install. So
Okay.
the umbrella system comes into play because of its ease.
Okay. So I think we can close this session here. We have a couple of questions from the audience that we would like to take up. The first question, I'm going to throw it open to all of you, and you can take it up whoever thinks is best suited to them. The first question that we have is, what is the material model to stimulate the interaction between snow cover and the bed debris? What input parameters would be required? Um, can you let me know who would like to take up response to this question?
To understand the snow cover and bed debris, base thing for to simulate it, we need some experimental setup to investigate the interaction between moving mass and if you have some uh, how much bed it can erode. So you can make the artificial channel, and you can study the bed erosion pattern also by putting various roughness factor over the bed surface and allow snow to move at near about means you need a experiment at least Froude number in the range of real avalanche. So by putting any flow 8 to 10 meter per second and flow depth 2 to 20 to 30 centimeter movement, you can generate the situation similar to the practical avalanches. Because if small the avalanches, then cohesive effect and other effect is so dominant so that it will not able to capture the real avalanche situation. So experiment need movement of the snow mass need at least above Froude number 5 to understand real life avalanche. Just like a Reynolds number, you define to understand the property of the flow around various fluid around various obstacle. You put the Reynolds number as standard parameter. Here you have to the Froude number as standard parameter.
Okay. Thank you so much, Dr. Kumar. Rudra, I believe since you've been talking about the umbrella system, we have a question on it. So someone's asked that which zone the umbrella system is installed for having maximum level of protection.
Yeah. So it's installed in the formation zone, the topmost zone, because we are trying to treat the zone to prevent an avalanche to form altogether, to mitigate the risk of a formation of avalanche. So it's installed in the formation zone, the topmost one.
Okay. Nadine, the next question has been directed to you. So the person is asking, do we also factor in the porosity and other properties of the soil or ground on which the snow is designed to be accumulated? Over time, when the snow melts, there would be runoff to be tackled and duly disposed of.
Okay, I'm not so sure if I got the question right, but actually the soil properties are used or are needed for the foundation, so that we know how and also for the corrosion. And yes, I mean, just like in general, if your soil is like warm or not warm, it depends a bit on when it snows, how the snow cover is mixed or getting connected with the ground. And yes, in springtime, when it starts to melt, you have that flow runoff underneath, and that can trigger or move a little slap, let's say. So I'm not so sure if I got the question right, but that you can take into account.
Okay. Thank you so much, everyone, for joining us here today. The session extended a little longer than we had anticipated, but thank you all for your patience. I would like to once again thank all of our speakers and Dr. Singh for moderating this session. It was extremely informative. I think a lot of people got responses to the questions they had asked. I would also like to thank Geobrugg India once again for sponsoring this webinar. We are extremely grateful. And to our communication partners, Kroll Mantra, and our platform partners, AirMeet, for enabling a smooth interaction. Thank you so much, everyone, for joining us. We will meet again soon to discuss another topic on the geohazard mitigation industry. Thank you so much.